Cool. All right, so let's get started. So demystifying cookie security in Rails 6. So everything in this talk is gonna be focused on Rails 6 because there were recently some changes around encryption and stuff. So yeah, if you're using Rails 5 or something, you might see something different in your application. So just gonna start with what exactly I'm gonna cover today. Start right with the basics of what an HTTP cookie actually is and what it's used for. The different kinds of cookie storage that Rails offers just out of the box. How the techniques that Rails uses to secure data that's stored in cookies, because obviously you don't want your data getting stolen or anything, and Rails has some really nice inbuilt features to secure data. And what security options you can set on the cookies themselves to prevent the cookies from being stolen. So even if the data is secure, if someone stole the cookie, they can use that to do bad things to your application. So there are some nice security features that you can set quite easily in Rails. And what I'm not going to cover is anything low-level cryptography, because I'm not a cryptographer. I'll just say the names of some algorithms that it's using, but I have literally no idea what they do under the hood. And I should also preface by saying I'm not really a security expert. I've just spent way too long reading Rails source code and MDN docs to develop a good understanding of this field. So if I do say something wrong, please do call me out on it. The obligatory a bit about me section. So like Frank said, I live in London and I'm originally from India. I worked as a mobile developer for about 5 years or so, right out of uni. And I used to specialize in iOS, but I did a bit of Android as well, depending on the job. And I did some work for some pretty big names like Dyson and Tag while I was working in an agency. And then I left and I worked at TransferWise in their iOS team for a couple of years until I left last year because I was just getting a bit fed up of Apple's quote-unquote walled garden. And given the debacle with Hey.com earlier this year, I think for me it was definitely the right decision. And I wanted to switch to web development because it's an open platform. It's not controlled by a corporate behemoth. And Rails was an obvious choice, firstly, because I admire DHH quite a lot, and I just really like the Rails ethos and the Rails doctrine of convention over configuration and how it kind of does a lot of the hard stuff, like the stuff I'm going to talk about today, just does it for you, and you don't, as a Rails user, you don't really need to worry about it. These days, I spent the last few months building my first SaaS product, which I launched called Chapter 24. It's a blogging platform, super simple blogging platform. I kind of built it so that anyone who's not technically trained, like they don't know HTML or don't know anything about hosting or anything, they can create a blog and have it up and running very easily. And they have a nice rich text editor to write in and stuff. So if you could use a browser, you could create a blog with Chapter 24. And I launched that a few months ago. If you're curious, you can check it out at that URL. And work-wise, I'm just starting freelancing as a Rails developer now. You can see my details. That's my email address. I'm Ayush21 on Twitter, and my freelance company is called Radioactive Toys. If you're interested in seeing any of the work I've done or my portfolio or anything like that, or ways in which I can help as a freelance developer, it's all on my website. Right. So let's dive straight in. What is a cookie? It's a small piece of data that is stored by the server in the user's browser. And it has to be small. The max size is approximately 4 KB. The exact number of bytes depends on the browser, but you really don't want to be getting anywhere near that ceiling. If you're getting anywhere near it, you really should be looking at other options. Also, it's sent to the server with every single HTTP request that the browser makes. So the bigger the cookie, the bigger the overhead on your request, and the slower the network latency will be. And You really don't want that. So a cookie should be as small as possible and as minimal as possible. And the main function is provide state to HTTP because it is a stateless protocol. But most applications these days, it needs some kind of state. Like if you're logged into an application, that is a state and it needs to be held somewhere. If you're in the middle of some kind of flow, that state needs to be held somewhere. And a cookie is usually the simplest and usually the best way of maintaining that state. So cookies on Rails. Rails has 3 types of cookies that it allows the user to store. One is plain text, which is quite obviously just exactly what you as the user specify is stored in the cookie. The other is a signed cookie, which it looks like gibberish, but it can actually quite easily be decoded. And but the thing is, you can't tamper with a signed cookie because it has a cryptographic signature. So the server, when it receives the cookie, it'll compare the cookie data with the signature. If it doesn't match, means someone's tampered with it, and it'll just nil the cookie out. And I'll dive into that a bit deeper later on. And the last type is an encrypted cookie, which unless you have the key to it, you can't see the data, and obviously you can't tamper with it because it's encrypted. And if you tamper with it, it's just going to corrupt the data, and Rails will just nil the cookie out. So yeah, you can't really do much with that either. So start at the beginning. Plain text cookies, which is storing things as is in a cookie. Really simple way to do it in Rails is just it's literally like setting a value in a hash. In a controller, you just have access to this cookies hash, and you can set a key and a value, and away you go. And what that line does is, in the HTTP response, if you inspect it, it'll add a set cookie header with a key and value. And all that stuff telling the browser to do is save this data as a cookie. And if you inspect your browser developer tools, you can see, sure enough, the cookie you set, welcome message shown true, has been stored over there. Now, plain text cookies are quite risky business because anyone can view them, anyone can change them. So you can literally just double click on that value and set it to false. And well, in this case, the worst thing that would happen is the user probably see a welcome message for the second time, which isn't that big a deal. But if it was anything more secure, like a user ID or something like that, you really don't want the user to be seen or be able to edit that. So plain text cookies should really only be used for simple things like storing whether you've shown a message or maybe the user's time zone, something like that. So for anything more sensitive, you want a more secure option like a signed cookie. So like I mentioned briefly at the start, signed cookie can be read by a user, but you can't tamper with it because it's cryptographically signed. And you can set it just as easily as a normal cookie. You just need to specify .signed ahead of your key and value. And that'll result in a cookie that looks like absolute gibberish, like that. It's just a long string of nonsense. But if you do look closer, it's actually 2 parts. It's divided by that double dash you can see towards the final third of the string. The left side is your cookie data. So in this case, I think it's 42, the string that I stored. And it's been JSON serialized and base 64 encoded. So base 64, for anyone who doesn't know, is just an encoding scheme to represent binary data as ASCII or as text. So that's all that is. And on the right side is the cryptographic signature. So that what Rails has taken the cookie data on the left, put it through a signing algorithm, and it comes out with a signature which it puts on the right side of the cookie. And when this cookie is sent back to the server, it'll recalculate the signature. And if it doesn't match, it'll just nil the cookie because someone's obviously messed with it. And if it does match, the data is still intact, and you're free to use it in any way you wish. Under the hood, this cookie uses signed cookies use active support message verifier to actually encode and generate this signed string. It's a great API. It has a lot of uses outside just cookies. And if you're curious, I'd recommend checking out the documentation. So let's dive into some code and see how you can actually decode signed cookies. It'll give you a good idea of what's going on under the hood with this. So first thing is we split the cookie at the double dash, because like I said, the left side was the cookie data and the right side was the signature. So all we want is the cookie data because that's what we want to decode. So we split it. Cookies are stored with the as URL escaped values. So just want to unescape it to get the actual value back. And we just, like I said, it's base64 encoded. So we just do base64.decode64, which will give you a JSON string, which we parse. And it'll give you a hash that looks like what you can see in the comments there. That's the hash that active support message verifier generates. The only thing we really care about there is the message. The other two fields are expiry and purpose. Those are used under the hood by message verifier for the purpose of cookies. Don't really need to worry about it, so just ignore them. So the message itself is also base64 encoded. So the message that looks like gibberish. So we need to decode that and then JSON parse that as well, which is what we're doing here. Just get the message out of the hash, decode it, and then just do the JSON.parse. And as you can see in the comments, what you'll get back is 42, which is the value that we stored initially. So even though the cookie looked like complete gibberish, what's going on under the hood is very simple, and it's quite easy to extract what data was stored inside the cookie. And since the data is JSON serialized, any JSON serializable object can be stored. The only thing is if you want anything that's not a string, you have to put it in a hash with the key value. So here, if you wanted to store some preferences with use dark mode is true, you need to store it in a hash and with the key value. So what will serialize is just the hash of use dark mode true, because if you put the hash directly, that's not going to work. And you can put any JSON serializable object in there. It doesn't have to be a hash. So because the signed cookies is base64 encoded, you can decode them on the client side using JavaScript. So there's a pattern I think that DHH wrote about almost 6-7 years ago now, that if you cache your fragments and you just cache the same fragment for everyone, and then on the client side you run some JavaScript to hide certain elements that the user doesn't have access to. Like maybe there's a button that only an admin has access to, and you just cache the entire fragment and then hide the button in JavaScript. And you're guarding the actions in the controller anyway, so it's not a security issue if someone manually makes a request. So a good way to kind of identify a user is store their identity in a signed cookie, and then in JavaScript you decode the cookie, and then based on that identity you can hide or show certain elements. So this code is literally exactly the same as the Ruby code I showed you just a couple of slides ago. It's just not as elegant because it's JavaScript and not Ruby. It's like I just unescape, convert to ASCII back from binary, parse it into JSON, extract the message, the whole shebang is exactly the same, just in a different language. All right, now let's get into the interesting bit, the actual digest. Let's see how that digest is calculated. So what it starts with is it takes what's called a secret key base. This is generated at random when you create a new Rails app, and it's stored in your credentials file in Rails 6 by default. So if you open your Rails credential files, you'll see this there by default. So that's kind of used for all kinds of encryption and signing in Rails. So it takes a secret key base, and it takes another string called a salt, which is just technically just a random input into an encryption algorithm. By default, for this purpose, the salt is just the word signed cookie, but you can change that with config.actiondispatch or signed cookie salt. So you can set it to whatever you want. And I'd recommend setting it to something else because you don't want it to be a default. It's just a security risk. So both these values are put through something called a key generation algorithm, and they give you a secret. And that secret is what's actually used to do the signing. So once we have the secret, we take our base64 encoded cookie data, and put those two things into a hash algorithm, which by default is SHA1. Again, this can be changed to something else with the config thing shown below, config action dispatch sign cookie digest. It's just a hash algorithm. Like I said, I don't know the inner workings of it, but for anyone not familiar, a hashing algorithm is just a many-to-one function where it takes many inputs and it'll always give you the same output for those inputs. And it's computationally too expensive to calculate the inputs from the output. So you can store data securely in a hash, but if anyone got their hands on the hash, they won't be able to get the inputs out because it's just computationally too expensive. So you put the secret and the base64 encoded cookie data into this algorithm, and out comes the digest, which is what we want. And that's just appended to the end of the cookie, and the cookie sent back to the client. And let's look at this in code. So how would we verify the digest of a cookie? Again, the first thing is we split it. We get the cookie data out. Get the secret key base for your application, which you can just get with rails.application.secretKeybase. And calculate the key with this funky-looking OpenSSL method. It's just the OpenSSL implementation of SHA1. So we just pass in our secret, the salt, which is signed cookie, like I said, which is the default. It runs for 1,000 iterations and with a 64-bit key. Now, what those things mean, I'm not quite sure. In the Rails source code, they commented that the 1,000 iterations was in consultation with the Google security team. So I'm guessing some very smart people have come up with that number. And these are this is just a Ruby implementation of a standard algorithm. So if you wanted to use this in another programming language, it's actually quite easy to do. So you just need to find the implementation of this algorithm for any other language. So once we have the key, we calculate the digest.
I want to jump in here real quick to say, so it is a slightly more than a SHA-1. So HMAC is, so SHA-1's a hash, right? And HMAC is a keyed verification hash in cryptography. And what that PBKDF2 is a password-based key derivation function. And so what this is doing is taking the value of secret, and then with these other parameters, which you could dig into, it is then generating a longer proper crypto key, which you're then using on that line there. So anyway, just wanted to give a little bit more, but thank you.
Brilliant, cheers, Frank. So now that we have the cryptographic key, like Frank explained, we can use that to actually come up with a cryptographic digest. So that's what's happening here. It's OpenSSL HMAC.hex digest. It's getting and then it passes in the SHA1 for the hashing algorithm that we want to use, the key and the cookie value, and what it spits out is that digest, as you can see, the long string. And then on the last line, we just compare the digest we've just generated to the second part of the cookie, which is the digest part, and it will output true, which means that we've successfully calculated the digest and no one's messed about with it, and the cookie is safe to use. And yeah, that's pretty much all there is to verifying a cookie digest. So let's just go over what we discussed in signed cookies. So you want to use these to store user data, that it's okay if the user views it, but they should not be able to modify it. The cookie data is JSON serialized and base64 encoded. The authenticity is validated using a cryptographically calculated digest. So when it goes back to the server, it compares it to the digest, and if it's been tampered with, the cookie is just nilled. The saved data can be read by just base64 decoding the data part of the cookie string, which is the left side. And it's completely safe to decode these on the client for use in JavaScript. And you'd use these for storing something like user preferences or maybe a user ID or something like that. Right, so the last kind of cookie that Rails offers is an encrypted cookie, which is the most secure kind. and it can't be read by a user because it's encrypted, and it can't be tampered with either. And it's easy to store, just cookies are encrypted, key value, just like a hash. And it also gives you a pretty long gibberish-like string. And if you look closer, this string actually has 3 parts compared to the 2 parts for a signed cookie. So the left side is the cookie data, again, JSON serialized. The middle part is something called an initialization vector, which is just a random input into the encryption algorithm for security. And the right side is the authentication tag, which you can think of in the same way as the digest for a signed cookie. So all that's doing is it just authenticates that no one's tampered with the actual cookie data during the process of decryption. All 3 parts in this case are base 64 encoded, not just the cookie data. And the underlying API is active support message encryptor, which, again, if you wanted to generate encrypted data outside of cookies, you can just use this API to do it. It's really nice. So let's go through how the data is actually encrypted. So again, we start with the secret key base, and we also have a salt. Salt for this is authenticated encrypted cookie by default, just those words. And you can change it with the config shown below there as well. And these two are both combined with a key generation algorithm in the exact same way as for a signed cookie. And once we have the key, we take an initialization vector, which is just a random input, the cookie data, and put them through an encryption algorithm, which by default is AES 256 GCM, which is a mouthful and a lot of acronyms. What that is just AES stands for Advanced Encryption Standard, which is one of the most secure encryption algorithms in use today. 256 means the key that we use to encrypt the data is 256 bits. And GCM stands for something called Galloy Counter Mode. Now, I read the Wikipedia page on that, and it made literally no sense to me. But what I could glean from that is that it kind of adds an authentication step in addition to the encryption. So the authentication tag that we spoke about a couple of slides ago, that comes from this Galloy Counter Mode, which is the default. And you can change this to this algorithm to anything else with the config attribute shown below. It just has to be compatible with OpenSSL Cypher. So you can look up the documentation of that class to see what else is supported. So once we take the 3 inputs, the key, the initialization vector, and the cookie data, put it through this algorithm, we get 2 outputs. One is the encrypted data, and the other is the authentication tag. And then all Rails does is takes the encrypted data, the initialization vector, which is one of the inputs, and the authentication tag. Base 64 encodes all 3 of them and combines them into a string and sends it back as a cookie. So how would we go about decrypting an encrypted cookie in Ruby? So we would obviously need the key, secret key base, and the salt, which obviously we have if we are the application owner. So let's start with just unescape the cookie. The first thing, because they're all 3 parts will be URI escaped, and then split it into 3 parts: the data, initialization vector, authentication tag, and create our cipher, which we're going to use for decryption with the default algorithm, like I mentioned earlier, as AES 256 GCM. Calculate our encryption key, so get the secret key base from Rails application. We use our default salt of authenticated encrypted cookie, and we put it through the same key generation algorithm that we used earlier for the signed cookies, the same one. Under the hood, there's a class called Active Support Key Generator that kind of abstracts away all the OpenSSL stuff for you. So you don't really need to worry about the low-level stuff if you're a Rails user, but I just put it in here so it's a bit more clear what's going on. Once we have the key, we set up a cipher for decryption and then add all the inputs, the key, the initialization vector, authentication tag, add all the inputs there and perform the decryption. That's what these lines are doing. And we get the cookie payload and parse it into JSON, and we get this hash that looks exactly like the hash we saw earlier with the signed cookie. Again, don't need to worry about the expiry or the purpose. That's used by message encryptor under the hood. All we really care about is the message, which is also, again, base64 encoded. So let's get that out, decode it, and parse it into JSON. And what we get is 42. So after all that massive amount of code, all we get is the 42 back. But that goes to show what actually is kind of going on under the hood. And if you have the keys, it's fairly straightforward to decrypt what you've stored in a cookie. And that's why it's so important to keep your secret key base and your salts secure and safe, because if someone has those, they can very easily look at the data that you've stored in the cookies. So let's go over what we discussed with encrypted cookies. They used to store sensitive user data.
I wanted to stop for a minute. You said about read the data, but from a security point of view, even worse is forging their own cookies. So for example,
yes,
if you use cookies for authentication, and someone has your secret key base and they can make their own cookie that says they're authenticated as any user, then that's a major issue.
Yeah, absolutely. And and then obviously if that was the case, you'd have to change your key, which Rails makes it relatively easy to do, but you don't really want to get yourself in that position in the first place. So best to keep your keys as secure as you can.
Well, if you do change your key, you invalidate all the cookies that are out there, in case people don't pick up
you can use key rotation to kind of gracefully do it. Mm-hmm. I don't know exactly how it works, but there is I did read some docs on key rotation where you can change your key, and when an older cookie comes in, it'll be decrypted and then replaced with a new cookie encrypted with a new key. So it kind of gracefully does it, but I don't quite understand how. But of course, I think you can do it in Rails.
Right, but if your key was compromised, you wouldn't want that, because then you would just be updating the cookie for someone who made a forged cookie.
Yes. Yeah, that's very true. So yeah, you don't really want to get yourself in that position. So it's best to be safe than sorry. Cool. So cracking on. So you used to store sensitive user data that you don't want the user to be able to see or modify. It's encrypted using AES-256 GCM by default, but you can change that. Data can't be read without access to the secret key base and the salt, which, as Frank just touched on, keep those very safe, because you don't want people forging cookies and then doing bad things. These can't and shouldn't be decrypted on the client. Do not send your secret key base and salt down to the client under any circumstances, because that's just leaving it out in the open for a thief to steal. And a good example use case is something like a remember token, which remembers a user's logged in state even if they've closed the browser and then they come back a few weeks later or something like that. So that's as sensitive as the password pretty much, so you want that to be as safe as possible. So those are the different types of cookies that Rails supports. So now we can dive into a little bit of the anatomy of a cookie itself. And cookies don't last forever. They have a lifetime, which by default is session, which means that when the user closes the browser, this cookie will be deleted, which isn't ideal if you want something like a remember token to stick around even after the users close their browser. So you can change this. You can set an expiry value. So when you're setting a cookie, you can specify some extra attributes on it. So you can set expires 7.days, which will mean it expires 7 days from that time, obviously. And in your developer tools, this is reflected. So you can see that the cookie last access was Thursday, 5th November 2020, which is when the change was made. And expiry was 7 days from then, which is 12th of November at the exact same time. Rails has a nice shorthand for storing permanent long-term cookies, which is permanent cookie jar, which you can chain with signed encrypted cookies as well. And what this does is set expiry for 20 years from now. So hopefully you won't have to worry about these cookies ever expiring. So something like remember token, the permanent cookie jar, is a perfect place to put it. So there is a special cookie that Rails has called a session cookie. Well, it's a session store, which is by default is a cookie. And in any application, you kind of have data that's specific to the session. Things like an authentication token, or there might be like a redirect location, or there might be some data about a flow that the user is in. And because there's so much session-related stuff that an application needs, Rails has the session store, which by default is an encrypted cookie with an expiry of session, obviously. It can be changed to something like memcache, but I think most people use cookies and it is the default, and it is encrypted. And you can configure this with config.session store. So you can, the attributes that we talked about, that we're going to talk about security and stuff in the next few slides, you can set those with config.session store. And if anyone's familiar with the Flash API in Rails, that's stored in the session cookie. So that gives you an idea of the kind of stuff that you would store in this. And yeah, it's just a hash in your controller. It's just session key value, and it'll go into your session cookie, which is encrypted. So it's completely secure. You can store sensitive stuff in there if you want. So now the last part of the talk is how do you guard against the cookie monster from stealing all your cookies? Because even though you secured all the data in your cookie, if someone actually steals even that encrypted data, they can do bad things with it because it's getting decrypted and authenticated on the server side. So they could, if they have a user's authentication cookie, they could just masquerade as a user and do bad things with it. So it's going to talk about the kinds of attacks and how we can guard against them using the techniques, using security techniques, and how we can access those techniques in Rails. So first thing is man-in-the-middle attacks, which means that someone has put themselves in the middle of a client and a server and is stealing the data that's being transmitted. Say if someone if the client is sending data to a server and someone's put themselves in the middle, that person can get all the cookie data and stuff. And if they get the cookies, they can obviously do bad things with them. Cross-site request forgery, which means that let's say you're logged into your bank and the bank has stored an authentication cookie on your browser, and you go and visit this other malicious website that is running some code in the background that you have absolutely no idea about, and it's making these HTTP calls to your bank. And because the bank has stored an authentication cookie, that cookie is being sent along with these malicious requests. So as far as the bank is concerned, it thinks those requests are coming from you. But this malicious user can do some, maybe transfer some money over to themselves or something like that without you ever knowing, because it's happening in the background. So there's ways to protect against that, which we'll talk about. There's a lot of, there's so many different ways someone could execute malicious JavaScript on your website. Like maybe an NPM module could be compromised, or someone's injected some JavaScript into your application through some vulnerability or something like that. There's just a plethora of ways this could be done. And again, there's ways you can guard against it. The final is physical cookie theft. If someone's actually got physical access to your machine and stolen the cookie, there's not much you can do about it. There's nothing you can do about it really, other than probably invalidate the data at some point. But I thought I'd mention it anyway because it is a risk, and it even though there's no foolproof solution to it, it's something just good to be aware of. So I'll start with a secure attribute, which means that any cookie with a secure attribute is only sent over an HTTPS connection. So it's all encrypted. So a man-in-the-middle attack is just out of the question because all the data is encrypted and it's validating the SSL certificate before the connection is made. So it completely eliminates man-in-the-middle attacks from the equation. But more importantly, what it does is it guards the cookie from being stolen if the first connection to a website is insecure. So like, let's say you go and type facebook.com into your browser, very likely what it's going to do is the first connection to facebook.com is going to be HTTP only. And then the server will upgrade the connection to HTTPS. Now, if someone has managed to intercept that first insecure request, they can steal the cookie data from that request. And worst case, they could even masquerade as facebook.com or whatever else, but that's a whole other can of worms. But if the cookie has a secure attribute, when that first insecure connection is made, the cookie isn't sent. And when the connection is upgraded to secure, that's when the cookie is sent. So there's no risk of any person managing to sniff packets and stealing that cookie. And yeah, it's just a secure true attribute, super simple to set in Rails. You can set that with any kind of cookie. And proof is in the pudding. You can see secure true in your developer tools. That means it'll only be sent when the connection is HTTPS. And you can set this globally in your Rails application by doing config.forceSSL equals true, which in any production application, you really should have it as true. There's absolutely no good reason not to have that set to true in a production application.
I want to go and share another bit there. You mentioned the downgrade attack. So you log in and then you go and type back the website and you hit the unsecure URL that's then upgraded to an HTTPS. Force SSL additionally sets another HTTP flag, which is not related to cookies but works with this, called HSTS Strict Transport Security. And what that does with modern browsers is it tells the browser to never talk to me on an unsecure connection at all, which is just defense in depth, where both the secure flag and also the fact that your user's browser can't be tricked to downgrade to an insecure connection. So it's a good thing to set.
Yeah, absolutely. So yeah, you kind of reduce the amount of risk because it's just the first ever request that's insecure. Then every subsequent request, even if you type HTTP manually, will be secure. So yeah, thanks for bringing that up. The next attribute that you can set on a cookie we're going to talk about is SameSite. Can be a bit tricky to get your head around, so just bear with me for a couple of minutes. It specifies the browsing contexts in which a cookie will be sent to the server. I'll get to what that means. The valid options for this attribute are strict, lax, or none. If you specify none, you have to specify the secure attribute that we just discussed. Otherwise, browsers will just treat it as an invalid cookie. The default value in most modern browsers is lax. So what do these things actually mean? So let's look at this image and let's start with strict. So let's think of the green box as our website. So a strict cookie will only be sent when the request originates from our website. So if someone has clicked a link to our website from some other page, or if someone has typed our website into the address bar on the browser, the request hasn't originated from our website. So a strict cookie won't be sent along with this request. And that is too strict for most applications because you want like if you're logged into Facebook and you click a link from another site, you don't want to see your login screen. You just want to go straight to the page, right? So which is why we have lax. So lax is a little bit more free than strict, and what it does, it'll send the cookie with any top level navigations. So what that means is if you type the address into the address bar, or if you click a link from another site, it will send the cookie along with those requests. But what it won't do is it won't send the cookie if someone has embedded your website into theirs, or if someone is getting some resources like an image or something from your website, the cookie won't be sent along with those requests. Now, if you want your cookie to be sent in a third-party context, which is when someone has embedded content from your site into theirs, you need to specify SameSite as none and specify the secure attribute. But I really wouldn't recommend doing that because Safari by default blocks all third-party cookies. And I think the other browsers, it's only a matter of time for other browsers start following suit, because primary purpose for this really is tracking users, which is slowly going out of vogue these days. So there are workarounds to, like, if you embed a YouTube video and also you want that logged in state to be held in that little iframe, and there are workarounds, but let's not talk about those for now. There is a really nice WebKit blog post that talks about how you can do that. But that's what SameSite does. It just specifies a browsing context in which the cookie will be sent. And I'd recommend setting lax for most of your cookies, because I think it's the right level of security. Again, just set an attribute, same_site, and it can be lax, strict, or none. And change is reflected in your browser dev tools, so you know it's actually doing something. And this can be set globally using Action Dispatch Cookies SameSite protection. This is not in the last release of Rails, I think, which is 6034, but it is in the 6.1 release candidate. So keep an eye out for that when it comes out. You can use this config attribute in your application.rb. And the last attribute we're going to talk about today is HttpOnly. So that means the cookie is only sent with HTTP or HTTPS requests, and it cannot be accessed using JavaScript. So this was the last attack that that I mentioned from the cookie monster with malicious JavaScript. So the best way to secure a cookie from JavaScript is to not let it have access to it in the first place. So you can set it as HTTP only true. The session cookie, by the way, by default is HTTP only true, which makes complete sense because it's quite sensitive data and you don't want any JavaScript getting their hands on it. And you can see it's reflected in your dev tools. And if you go into your console and do document.cookie, you can see it'll return nothing, which means that even though that cookie is set, JavaScript doesn't have access to it. So let's sum up everything we spoke about today. So you can keep the data in your cookies secure using signed or encrypted cookies. Signed cookies obviously can be read by the user, but they can't be modified because they're signed. And encrypted cookies, they can't be read or modified by the user because the data is securely encrypted with your secret key. You can prevent man-in-the-middle attacks by enabling SSL on your website and using the secure attribute on your cookie. You can cross-site request forgery attacks by setting the same site to lax or strict. So if someone tries to make requests to your website from a third-party context, your cookies are not sent, so they can't make unauthorized requests that the user doesn't know about. And you can restrict access to any potentially malicious JavaScript by setting HTTP only to true. Now, I also like to say that nothing is ever 100% secure. My networking lecturer at university used to love saying that the only way to completely secure a computer is to dig a hole 10 feet into the ground, line it with lead, put the computer in there, flip back up, and then maybe, just maybe, it might be unhackable. But none of these techniques is a foolproof security solution. And by all these together, I think it'll give you a really good, it'll protect you against, I think, the most common kinds of attacks. And even so, security is something you should take quite seriously. And one oversight in one place can cause an issue somewhere else completely. So application security should be looked as a whole and not just bits and pieces. And just finally, I just want to say special thanks to Frank for inviting me to give this talk. It was really good fun putting this together. And check on my blog at binarysolo.chapter24.blog. It's obviously run from my own blogging platform. And the last post on there is actually about 80% of the content of this talk. And it has loads of links out into the Rails source code and the Rails documentation. So if you're curious about how some of the stuff I spoke about actually looks like in the Rails source code, check out the blog post and you'll see the links, and it'll take you straight into GitHub and you can see the Rails source code. Yeah, that's it. Thank you very much.
Thank you. So now we got the questions. Who has some?
I have a question. The code snippets you showed to decrypt the cookie and verify its authenticity, Rails actually does that for you, right? This is just to show how it works.
Yes, absolutely. It's all handled by Rails, and I even dug into the Rails abstraction layer. So even if you're using it's kind of abstracted with the active support, message verifier, message encryptor, and key generator classes. So you don't, even if you're trying to do something manually, you don't need to dive deep into OpenSSL. I just dug deep just for clarity and just to kind of demonstrate where Rails does it all for you.
Nice. Yeah, thanks. It was interesting to see how it works under the hood. Thanks for sharing this.
Cheers.
I never knew you could change the salt, and I've been doing this for almost a decade. I mean, I know it's a new feature in Rails 6 too, but that's great. I really appreciate that.
Cheers. I'm glad I could share that.
So, good question. So if you're using let's say a Rails default setup, it seems like from a user perspective, the two things you would definitely recommend would be turning the force SSL on, which I don't think is on by default, and then also setting the config.action dispatch cookie same site protection is also, I think, not set by default, or is it actually set to lax by default?
It's not set. In Rails 6034, it's not set. And the browser will treat it as lax by default. But yeah, I'd recommend setting it to lax. And you can do that globally from Rails 6.1. But before that, you're going to have to do it manually on all your cookies, unfortunately.
Gotcha. Are there any other sort of default settings that you would recommend people change right off the bat? If maybe they just have a stock Rails app.
I'd recommend changing the salt to something secure, like maybe just a randomly generated string, maybe something that one password generates or something, and store it in your credentials file, and then read it from your credential file and set it as a config. I think that would be really good, because if you leave it as the default, then all the attacker needs is your secret key base. If they have that, then they can use the default salt and start forging cookies. But if your salt is also something non-standard, then that's two aspects that the attacker needs to steal.
Makes sense.
You can actually generate secrets with bundle exec rake secret, and it will make the secrets like you have, it initializes with. You don't have to use 1Password or something like that to make them.
Cool.
It'll spit it out, and then you can upload that to an environment variable or your secret store if you're using like the AWS Secrets Manager or something.
Personally, I'm a big fan of the Rails credentials file. I think it's new for Rails 6, but yeah, I love how you can just store everything in YAML and it's just encrypted, and all you have to do is put your master key as an environment variable.
That should be its own talk. It is nice, and it bites real hard in business circumstances. So
yeah,
I am not a fan of putting secrets in the repo, even encrypted. But that's a different talk.
Yeah, absolutely.
Anyone else?
Just want to comment, thanks to those code examples you shared, I also realized why secret key base in the config is called secret key base and not secret key, because that's not the actual key that's used. They, put it through that key derivation function.
Cool. Yeah, that was actually something I learned as well when I was digging through the Rails source code for the content of my blog post. And if anyone wants to try out the code examples I demonstrated, you can just look at my blog post and copy paste it from there. It's all the same. I've just copy pasted from the blog post into slides. That's all I did.
And I want to share a little bit about the why the HTTP only matters, if you don't mind, on it, Ayush.
Yeah, absolutely, please.
So, applications have, different functionalities to include content. So if you're writing a blog engine, for example, and you allow JavaScript to be included, you might think to filter out certain attributes with your loofah configuration, or maybe you use action text, which does a pretty good job. But it turns out there's lots of ways to execute JavaScript in a domain, including an embed tag. So for example, even if you filter out, say, script tags, but you left the embed tags, you can end up executing JavaScript, and then that could steal cookies. You can also do it with attributes, like an image tag can load an SVG file, and the SVG file can contain JavaScript. You can use an image tag and have an onload attribute, and the onload attribute can execute JavaScript. Action text is a very good way to go, but if you have an older site with like TinyMCE and you don't get your sanitization very good, then you have a lot of vectors for cross-site scripting, and the HTTP-only really helps protect those cookies from being stolen, which is a big deal with that class of vulnerability. Just a little extra there.
Yeah, it's really interesting the kind of crazy things attackers think of. It's like, as an application developer, for me, it's hard to get my brain to think in that way, but it's quite interesting to see, explore how an attacker thinks to kind of explore every little gap in every possible way.
If anyone's interested in that, I highly recommend the podcast Darknet Diaries, which is sort of like semi-technical, but just amazing storytelling about crazy hacks, and it blows my mind. Like I feel like I'm so insignificant compared to how clever some of these attacks are. One of them being making a company think they were attacked so they would hire a company, and the scam was to get them to hire the company, which was like genius, just ultimate genius.
What's the podcast called again? Sorry?
Darknet Diaries.
Okay, brilliant. I'll write that down.
I'm gonna send y'all something here real quick in this link. This is a safe payload, meaning this is something my company uses when we're doing security reviews. But this is a smiley face in an SVG, but if you open it, it'll pop up a JavaScript alert, which I can show on my screen. It says nothing to see here, just some JavaScript. But if you actually click View Source on this, you can see how it actually works. So an SVG file is actually a script file with markup and stuff.
Frank, before we jump off, I had one more thing. I think I sent you. We got another free JetBrains license for IDE. If anyone wants that, I can. I don't know how you want to dole it out, or if we just want to see if someone is interested on the call. I'm happy to forward it to you.
Let's start with. I mean, if someone's like, I will explain what it is a little bit more. If someone's just like, sure, absolutely, that changes my life, we can let them have it. Otherwise, we could do some sort of little off-the-cuff contest right now.
Sure. Yeah, so JetBrains is a very popular maker of IDEs. They're the ones who make Android Studio, the Android Studio is based on their open source, make a very popular IDE for Java called IntelliJ, but they also make a Ruby variant called RubyMine, and it's probably, in my opinion, the only one that's an IDE that you should really consider if you're going to look at IDEs. So they generally every month give us a sort of a voucher that gives you access to any one of their IDEs for 1 year for free. Otherwise, typically it's like $5 a month or something like that. So we've given them that before, but if anyone on this call wants one, I'm happy to forward you the voucher.
Speak up.
Hey, I will take it. I'm a new dev. I was just looking at RubyMine.
I'll take one.
I've got
too.
their free trial. So.
Do we have one or two, Riaz?
Demetrius over there is fine as well.
Yep, I'll take one too.
So I have one right now, but they usually give it to us every month. So does one of you want to volunteer to not get it this month, or we can do some sort of contest?
You can take it this month. I'll take it next month. I'll look for the one next month. I'll be back.
Okay. Okay. So is it Matt? Is that right? Or
Mattia, yeah, yes, sir.
Tia? Okay, cool. Yeah. So if you here, I'll do this. I'll put my email address in here, and if you just want to send me a note, I will forward it to you.
Sounds good. Thanks.
Okay, great.
Awesome, and welcome. I love when new devs join us, because
Yeah, a little bit of fresh blood.
yeah, well, Ruby is a beautiful language. It's a lot of fun to work in, and one of the things I like a lot about it is it's probably the most friendly dev community I've ever been part of. So, I mean, not that others are bad, but I think Ruby is a little extra friendly.
Oh, I can vouch for that, I think, with my limited time so far.
Well, Ayush, you did a wonderful job giving us a deep dive into some of the stuff going on with cookies. And I think that the complexity you saw here should be an eye-opener to the sorts of things when we talk about Rails having really good defaults. Or Dave, what's the Japanese word that the Rails community likes to use for it comes with all the features? I don't know. It's like a sushi term or something. I can never remember it. But
I'm Japanese, but I don't speak Japanese.
Okay. There's a Rails principle that people say it is. I could find it somewhere. Anyway, the point is it comes with really good defaults, and not every platform does that. So you say, hey, force SSL, and set a few values, and the truth is that your cookies are going to be pretty darn secure. By default, your session cookie is an encrypted cookie. Ayush talked about how that keeps it from being stolen, and it keeps it from being forged. More importantly, if you have something where you need your JavaScript application to be able to read it, but not necessarily write it, you can use signed cookies. You have all these options at your fingertips, and you really don't have to write a lot of code. And the Rails platform developers have put a lot of thought into making it really fortified for you. And so that's a really powerful thing.
Yeah, I love Rails. I've only been doing Rails for about 10 to 12 months now, and it's just stuff like this that I absolutely love. I just dug into this because I was curious, but as a Rails user, cookie security is just something I wouldn't have to think about if I didn't want to. And I just love that about Rails.
Awesome. Yeah, I just posted the word. The word I couldn't remember is amakasi. Rails is amakasi. It's just not a word I know outside of this blog post.
I think, does that mean that it's the chef decides? I think that's what it means, right?
Mm-hmm.
Now, I've had this discussion before. So with Rails, you can dig in and you can break the defaults, right? If you have to, you can get in there and change it the way you need it to be, but you don't have to. In a lot of other platforms, you have to spend a lot of time writing configuration and telling exactly what to do, and there's not some stuff. I've definitely run into some practical areas in coding where I've had to break the Rails defaults, sometimes for my own reasons. So, for example, if you're writing a website that SEO is very important, then normal REST routes is probably not the way you want to go. You want to structure your paths very specifically for search engine purposes. So you can go into the router and you can start making objects having slugs, and you can make custom routes that send those to the right router. You don't have to do thing_thing/number/ something. You don't have to, but that's good for a lot of things. Databases, Active Record does a really good job saying this thing talks to this table, but let's say you have a legacy database, you can sit there and specify table name and specify primary key, and you can map whatever you need to. So it's good defaults, but it lets you have the power if you need it.
Yeah, I think that's part of the Rails doctrine as well. That it's I think the exact words are sensible defaults. I think so. it's quite beginner friendly because you don't need to worry about it, but changes are always there if you wanted to go and make them, which is a really nice way of going about things, I think.
Very awesome.
Was there any feedback that anyone had maybe on my presentation? Because I haven't given one in a long time, so I was a bit rusty. So I was a bit worried about how my delivery is going to be.
I thought it hit the right right notes. Your slides, obviously you're presenting code, so there's going to be, you're either going to live code that or have slides like you did now. I kind of like that scrolling effect. I hadn't done that. I hadn't seen that before. I thought that was clever.
It was a pain in the ass to do, but I'm glad I did.
And but I thought the overall topic, you didn't overwhelm, but you kind of kept on a good path. But what about for some other folks that maybe didn't know what the topic was about as much? I also had a chance to read them before, so I might have, been familiar.
I thought it was really good. I mean, it's sort of like, it's like when you watch a good movie, you kind of remember it afterwards. It's like, I feel like the test of a good presentation is like, okay, half an hour from now, will I remember something from the presentation that I learned? And, that's not always true. And I thought in this case, I actually learned how cookies worked and how Rails worked. And I feel like I actually learned information I can use in my life. So I thought it was great.
Thanks, Riaz. Really appreciate that.
Yeah, same here actually. I'm still in my undergrad, and Ruby is really new for me. I've only been experimenting it for the past year or so, and I felt like I learned a lot about cookies and stuff in this talk, so thanks.
Thanks, Annie.
So we talked a little bit about key rotation, which wasn't on your slides, but you mentioned it. So in a case of a compromise, key rotation is a bad idea. I mean, you have to rotate it, but you really do need to stop the bleed. Detecting that's another issue. But the documents you read, did they seem to provide a good, like, any idea about how often they were recommending rotating keys or any of that sort of meta strategy?
No, there was no recommendation like that in the documentation that I read. I think it was the key rotation, if I remember correctly. It's been a couple of weeks now since I went through all the docs, but it was really more a case of being upgrade friendly for Rails rather than to guard against a compromised key. So I don't really know how often it's recommended to rotate your key. It's probably something to speak to experts about. I guess it depends on the context of your application as well, and what kind of data you're storing in the cookie. I mean, if it's just an authentication token and stuff, and it's not. I mean, if you're not Facebook or something like that, I think the security risk of your key becoming compromised is going to be pretty low. So, not even sure if it would be worth rotating a key.
Well,
But
I mean,
I guess if your
really
application is
depends,
going to be
right?
high risk.
Like if your key was in your Git repo and now you're like, oh, that's bad that our key was in our Git repo, but you had no proof that it was compromised. You might choose to rotate it to a newer credential and let it run for a couple weeks before. You could make that as a risk judgment as a company.
Yeah, absolutely. So I guess it depends on the context of the application, the company, the environment, and probably a million different things.
I'm going to share a
I don't
link
think
with
there's
everyone.
one right answer to it.
Yeah, I'm going to share a link with everyone. So OWASP is called the Open Web Application Security Project. Amongst the projects is something called the ASVS. And so if you think, hey, we have an app, but what security things are we missing? You can sort of do your own. It's not easy, but if you would probably want to make sure that you at least met the level 1 controls based on the standard with your application. And Rails will help you meet a lot of those by default, but it definitely has a lot to say about cookies and the headers and things that you showed today. And it's a security standard that's an actual standard in the industry, not just a blog post. So has some authority.
Yeah, and some companies, depending on their size, they may actually have policies on how often secret keys must be rotated. So any kind of API keys or anything that you're using has to be rotated once a year, every 3 months or something. And Rails does have a guide on rotating encrypted and signed cookies. So they actually thought of that and put that in their guides. They just show a generic example of rotating them from a signed SHA-1 to a SHA-256. But they also put a link into the message encryptor where you can kind of dive in and see a little bit deeper on how you might be able to do that with the actual token.
Has anyone ever actually set a plain text cookie in their Rails app? I can't think of a time I've said, I want to disable all the securities and just use plain text, thanks.
I've done a plain text before,
Okay.
where someone can choose dark mode or not.
Okay.
I'm kind of curious as to when it would really make sense to, I guess, yeah, from that perspective, if you wanted to be right on the front end, would be the main use case, which I guess I haven't exactly had, because otherwise I would just use session storage, which is just encrypted by default, right? So that's interesting, yeah.
I guess
Yeah.
if you set a cookie from your front end, like maybe like a time zone or something that you kind of have to use JavaScript for because the time zone's on the client, maybe something like that would be plain text, and it doesn't really matter if the user messes about it. So I guess I haven't used that personally, but I guess if I was to, that's probably one of the only things I'd use it for.
I think in the past,
Yeah.
and it's not there now, I used, I could see using this, like on my website, it's not Rails anymore. At one time it was. It's statically compiled, right? So it's really fast. It's on Netlify. I could see maybe setting a cookie like as people visited the pages, and so that when they contacted me, maybe I could see, oh, they read the About Me page and they read a blog post. I mean, I know there's other ways to get analytics, but like just some like micro tracking in my own website that doesn't like leak their information to Google, that helps me see like, oh, they read this page and then they contacted me. I could maybe do that with a plain text cookie with a little JavaScript just on my own domain or something. I mean, I'm sure there's other things to do other than friendly tracking versus like scary tracking, but
to your knowledge, are there any specifics outside of the one thing you mentioned with Firefox that, like, you know, as browsers are trying to change their rules on privacy, that like are going to change in the future based, you know, in terms of how Rails has to handle cookies, or is it really mainly that? Which I know that a bunch of people have been finding that the like not setting lax explicitly is causing a bunch of deprecation warnings inside of Firefox. But is there anything else that you've noticed or know of?
Well, Safari's banned all third-party cookies, so I think that was quite recent. I think it was earlier this year, if I'm not wrong. So that's something to keep an eye on. Yeah, the SameSite thing, like you mentioned, is I think Firefox is taking the lead on that, and it's gonna get stricter, I think. But apart from that, from anything that's to come in the future, I'm not aware of anything else that might make life more difficult. As long as you're not trying to do anything weird like track users without consent or something. You're using cookies in the way that they're meant to be, I think it should be fine. And maybe Frank knows a bit more, I don't know.
that's about what I know too. I was going back to my mind about the salt and the fact that the salt set on a per request basis, or is it set for the application wide?
It's just application wide. The default,
Okay.
if you go into your console and do rails.application.config.action dispatch whatever the thing that was that I showed on the slide. I can't remember.
Right.
It'll give you the salt back, and that's the same for your entire application.
Okay, so yeah, it wouldn't help you with the whole log me out from all my other devices, or log out. Here's a list of all your devices that are logged in. Log the phone out, which you see in some apps. You would still have to do some server-side identification of
yeah,
devices.
absolutely. If you want to do that, you're gonna have to store like each individual session and probably like store an identifier in an encrypted cookie, and then store a digest of that cookie in a table, and have it like a
Yeah, you're gonna have to have like a
relationship.
session, your own session, UUID and track it, and you'd have That's actually one of those requirements with the ASVS as you go up in scale, is they start to require, as a matter of policy, allowing people to do device management where they can see from where they're logged in and they can kick out, or at minimum, a requirement is a changing password kicks out all sessions across all devices.
I think that's very important. And actually, I have another blog post. If you look at my blog, the first ever blog post that I posted is about how you can, if you don't do your authentication properly, and if someone steals your session cookie, they can access that user's account in perpetuity.
Yep.
And that happens if you use only the user ID as an authentication instrument and you don't use anything else, because the user ID never changes. So if someone steals that cookie, that user is screwed. And the way to guard against that is you use another authentication token in addition to the user ID. So when the user changes their password, you just invalidate that authentication token, and then if anyone has that cookie, it's useless.
Yeah, or you can, if your design calls for only one login at a time, you can just every login changes that token, and then that becomes reference. But absolutely, that's a big deal. Thank you for bringing that up.
I think there was a really nice RailsConf talk earlier this year about this very thing, and that's kind of what brought my attention to it, because when I was building Chapter 24 in the summer, I had it so that the authentication was only checking the user ID. And then I saw this RailsConf talk, and I'm like, shit, should probably not do it that way then. And I think from what he said in that talk, it's quite a common pattern. So I think it's definitely something that shouldn't be ignored. But invalidating a user session, because you never want to create something that any kind of key that gives you access in perpetuity to an account. That's just really bad.
Well, it goes beyond that too. So not everyone may know. I do a fair number. My company is a security firm. I mean, we do a lot of Rails and Rails maintenance. That's probably half our business, and the other half is, auditing and make me this thing that's unhackable. So one of the things I've seen in code reviews, and quite honestly, when Devise got rid of the Devise token, I keep on seeing it where the authentication token is stored in plain text in the database. And the thought is it's this very random value, so we want to be able to look it up, right? So we're going to take this random value and we're going to use it to look up the record. It's actually better to use a session cookie that uses the ID and then a random value, and then to actually store that random value the same way you would store a password. And in Rails, you can actually store it as a has secure password field, which uses bcrypt. And that way, if your user's table, for example, became compromised, someone wouldn't be able to use that information to forge valid authentication cookies, even if they had your secret key base compromised as well. So that's something to keep in mind when you design stuff, that not storing things like passwords for sure, but also not storing things like verifiers as plain text is a very important design consideration.
I believe bcrypt is what Device uses under the hood as well. So that's, I think, the most popular authentication library. And
Yeah, and what I just explained would
bcrypt as
use
well.
bcrypt by default. That's pretty much the favorite with Rails. scrypt and Argon 2 are both very good algorithms as well. But honestly, bcrypt is good enough that most of us shouldn't be worried about that selection. Meira, I saw you start to say something. Would you like to ask a question?
No, I wanted to say thank you to Ayush, for the presentations. I know when you post the video, I'm going to watch it twice and to understand what I have to change or compare my code when the things that you are showing us. But when you were talking about OWASP, I remember like a month ago, I was in a meetup that they were teaching you about OWASP, because one time ago I thought it was just a checklist when you have to accept things or things like that you have to fill in your code or what you have to present, right? So there was a web page when maybe you know about it. It's this iReals risk. I don't know if you have heard about it. Risk. So this was the guy who was making the presentation. He just tried to modulate your architecture and based on that, you can see the checks that you have to fill. So it was really interesting because I could understand now about OWASP and the things that I know I have to learn in a moment in my time as developer. But that is something that I want to share. Maybe you know more about this company or this web page that I've written in the chat, and it will be something to investigate. That's all that I wanted to share.
Thank you. I'm not especially familiar with Iris Risk. There are a lot of different security products, but thank you for sharing that. It's worth a look. Well, Ayush, I think we probably all can say thank you very, very, very much for staying up extra late to talk to a bunch of Rubyists who you haven't met in person about cookie security. I think we all learned a great deal and can appreciate that we don't have to worry about some of these details. It's just there for us to use. So thank you. Thank you.
Thanks, Frank. Thanks for having me on. It was really nice to meet all of you virtually, and thanks everyone. Thanks, Meira, for your words. And thanks everyone else who enjoyed the presentation. I'm really glad you found some value in it. And it was really nice to virtually meet all of you. And hopefully, I'm quite nocturnal, so hopefully I'll be joining again if I'm feeling awake enough for future meetups. But yeah, it was really nice. And if something wasn't clear in the talk, maybe you can just go read my blog post because it's all written down, so it might be a bit more clear. It's pretty much the same content. So yeah, do check me out on Twitter at AyushN21 or get in touch if you want to chat about anything. And yeah, thank you very much for having me on.
Awesome. Appreciate you. So that's a wrap.
Frank, do we have a talk for next month?
One of the gentlemen in the previous had volunteered, but I hadn't heard what the exact topic is. But I can follow up with him to confirm that he plans to do it. If
Cool.
not, does anyone want to be our January or February presenter?
I'd like to give a presentation, although I don't have a topic. So if someone has something they want to know about, I'm happy to learn and write a presentation on it.
I'm
I'll have
sorry.
the
All I can think of
Apple
is how to
Silicon
estimate
by now.
software. I'm sorry. I shouldn't go there.
So I know, I mean, this is something that we're starting to look at in terms of how to implement, and so it may not be a bad idea for me to learn, but have we had a talk recently about all the Rails multi-database support and how to actually use it in production?
Ooh, that could be good.
Mhm.
I don't think we've had a talk on that. I mean, I
Okay,
know there's
cool.
Drifting
So
Ruby episodes on it, but I don't think there's been an ATL Rug
Yeah.
talk about it.
Yeah, I've actually had to do that a bit. So
Mhm.
I was creating a new microservice for something, and essentially I didn't want to have to communicate with all these other databases in order to just fetch the pieces of information that I needed. So what I ended up doing was using Rails 6 API to attach to all of these different databases to pull the data. And the super awesome thing about it, I mean, this just blew my mind, is that let's say if I have two different databases, one has all the lists of companies, another database has all the lists of users. Well, my application has no knowledge of the association between those. I can create the company table or the company active record class to pull the data from that specific database. I can have the user model pull the data from the specific database of the user model. But then I can create a user class inheriting from active record and says belongs to company.
Yes,
And then I can
across.
go
I
to the
know. I just did
company
this in Rails 5,
and
believe it
has
or not.
many users. And it is amazing because it just works. It pulls the data and it just works.
You do have to be
That's
careful
super cool.
about, now, I
Mhm.
don't know, your case may be different. You do have to be careful about things that would generate joins and things probably won't work as well. But as far as querying, it absolutely works. It's amazing.
Yeah. And you have to be careful because if that database is being used by another application,
Yeah.
even another Rails application, and they have callbacks whenever a record is created, updated, destroyed, or whatever, those callbacks won't get fired at the database level. It has to originate from that particular application. So you have to be very careful on what you're touching and making sure that you're just read-only, which you can just pass in a read-only parameter within your model, and that would set it to true. It will prevent writes back to that database.
Right. Yeah, it's pretty exciting. I actually
is cool.
recently had because you and I had a conversation, Dave and I had a conversation related because I was like stuck. It's kind of like when you get it to a place where it's like where we're going, there's no roads, there's no maps. That's how I always feel sometimes when I'm about to embark upon an Ayush style like deep dive into the innards of Rails. And it turns out that you actually can in Rails 5 if you're willing to do some custom stuff. Do things like connect to a database based on an environment variable that's different than the database specified in database YAML, and you can start to do some of the same things with Active Record where you say, set the primary key, and then you're like belongs to company, where company might be in your main database as long as that ID matches, and it's pretty crazy because crickets. Like, you can Google all you want, and this is the kind of stuff that either no one does or no one talks about in Rails land. So that's I guess, Riaz, that's 2 votes of that sounds really cool.
I always find it's really good to volunteer to give talks and things I know nothing about, because then it's the best process, because I'm like, I don't want to look like an idiot, so I better learn this really well. So it's a good tactic for me.
Can do one on the new Apple Silicon.
Yeah, well, yeah, that's one that's coming up.
Well, I guess I'd have to buy one of the laptops to verify. Actually, Dave, you said you were going to buy one. I'm actually curious. Maybe that is a worthwhile investment, because I am very curious to see how well things run on it.
Well, so I do have the TDK, and it's been really disappointing as far as speed goes. So I'm really hoping that this M1 chip is going to be a night and day difference. For example, compiling OpenSSL took about 20-30 minutes.
Are you talking about the new translation software?
Yeah, this was using the Rosetta 2.
Oh, really? Yeah,
Yeah,
according to
no.
their claim, it was only supposed to be a 5 or 10% performance hit, but you're saying it's pretty much worse than that on like testing on an iPad or something?
Yeah, so we'll see what happens. But so I did go ahead and pre-order the 13-inch MacBook Pro with the Apple Silicon, so I can do a Drifting Ruby episode on that. And then also, I'll probably give it to the wife once I'm done tinkering with it. Unless if I really love it, in which case I'll keep it.
Yeah, I mean, I'll hold judgment to after I see Dave's Rails drifting Ruby on this, and his ATL rug talk apparently. However, I mean, I'm probably off the Mac ecosystem at this point. Once I'm going to use my 2014 as a light editing system, and probably until it dies. I'll probably go ahead and pay to change the battery in it. And we'll see what I do later. But I don't know, Riaz. Those are some pretty premium prices that unless you're just really getting something that you need, I would really be tempted to wait till the next generation at least and see where it goes.
That's my
Well,
first
until we
thought,
get
too.
until we get them in hand, I mean, they're promising such dramatic performance improvements. I mean, it's they could just be blustering, but these are shipping in a week or two. So I don't know how many people are pre-ordering and then are going to be like, well, this is not that much faster at all, or is much slower. I don't know if it's much good incentive for them to be blustering that much. So I guess we'll find out, but it might be that they really mean that it's got, dramatic performance improvements for applications that are optimized for it. And that might be a pretty small
what we're
number
going
of
to find out
applications.
it is. I really do.
Yeah.
Because
according to them, though, optimizing your application in terms of exporting a different binary should just be recompiling an Xcode, where pretty much all the APIs should pretty much work, but it might take some time for everyone to hit that button, and there could be some C extensions that won't compile correctly.
I'll see the proofs in the pudding when Homebrew is completely available.
Yeah.
And right now there's also a major, in pure open source, there's some license issues with Apple's compiler. So unless you can use GCC to target it, for a pure open source licensing perspective, compiling with a proprietary compiler can be incompatible. Obviously, as an individual, we can do it, but and then I do think that I'm not as familiar with the details, but I know they were marketing that some sort of like machine learning acceleration, like on-chip acceleration capabilities. It's almost like a GPU, or it's like it's using the GPU or something like that to make certain classes of things run even faster than they would on a standard processor. That could be interesting if you are doing on-device machine learning.
Interesting, yeah. I do agree with the open source part. I didn't really think of that, because obviously if you're targeting it, you'd have to compile for it. And so, yeah, I don't know. I mean, we've been through the licensing issues before. I remember with the change where React was trying to change their licensing, that ended up in a debacle. So we could have one of those in our hands.
Right, and the other thing is, how do you do CI/CD targeting, which Apple's been problematic for that for a long time. With, I mean, you end up with Mac Minis in a data center because you can't just. I mean, the reality is, one can, following instructions that are on the internet, run the software in emulation and do what you need. But if you are above board and following the license, there's a lot of real problems.
Yeah, it's well, if you're not targeting them, like if you're writing a Ruby application, you're just writing web code and then essentially delivering it to your own machine to run.
Yeah.
You might not be as affected, except for performance implications in your local dev machine for some C extensions. But if you're obviously writing for Mac, for OS X, you probably already had to run a Mac. But yeah, if you are writing open source OS X applications, that would potentially be problematic licensing-wise, I can imagine.
Yeah, for the projects, like it'll be problematic to release an official project distribution of the open source package.
Yeah.
So,
Yep.
Anyway, who knows? That's where Dave's gonna give us the deep dive. He'll be like, "Oh, it's super slick. My battery life, I didn't have to charge it for a week and a half." No, let's get real. You open Slack and 30 minutes later it's dead. It's like, please charge me.
So I actually, one other one, this is a topic that I'm not particularly interested in, but I'm actually really interested to learn about, is just sort of the history and the actual meaning of various software licenses. Like, I feel like I use them and I know which ones to generally avoid, right, which is like GPL v2. But it'd be interesting to just know the history of software licenses and actually, in maybe some detail, what each of them means. So if people are interested in that, I'd be happy to do that one in January.
Very, very cool. Well, y'all, it's getting late. I've been sitting at this desk a long time today. So, if everyone wants to stick around, that's fine. Otherwise, I say, see you next month.
I'm going to clock out as well. It's 1:23 a.m. out here, so I'm going to go to bed.
Oh, that sounds like a good idea.
Well, yeah, thanks again for having me. It was really nice to meet all of you, and hopefully I'll try to join next time as well. It's an absolute blast, so looking forward to the next presentation.
Love it. Thank you, Ayush. Thank you, everyone.
Yeah,
Have a great
welcome.
evening.
Cheers. Take care. Bye.
Bye.